Hi there, welcome to another math video notes number 2. Today we're working on multiplying fractions and mixed numbers. So using your notes template given today in class, let's fill this out, why don't we? So multiplying fractions, what does that involve? Well, first things first, if you can cross reduce or cross cancel, remember we had notes in class today about cross-canceling? If you can do those things ahead of time, it's basically simplifying the fractions before you have to do it at the end. So you do it in the beginning, it saves you a little bit of time at the end, but also makes the numbers a little bit more manageable and smaller. Okay, first things first, let's multiply the numerator by, guess what, the numerator. So the numerators basically multiply each other, and there's nothing to worry about as far as the denominator. Because for the denominator, in multiplying fractions, is basically you're going to multiply the denominator by the denominator. There's no need for common denominators because you're just multiplying. And that's what makes multiplying so much more fun and a little easier when dealing with fractions. Okay? So let's look at the last step, of course. Always the last step. What's the last step? Well, of course, if you can, you simplify. Sometimes we need to simplify because the fraction is not in simplest form. Other times it's in an improper fraction form, and that needs to be converted into a mixed number, which would be the more simpler term. Okay, so let's see. Let's get some examples down, of course. We want to see some examples to know what we're talking about. So first example, let's look at, let's have 8/9 times 3/5. And remember, there are different ways of showing multiplication. So one of the ways we used before was the x. It looks, to not be confused with the letter x or variable x later on. We can also use a dot to represent multiplication. So this is another symbol for multiplication. So first of all, we want to see if we can cross cancel or reduce. 8/9, it's already, you can't really reduce that. 3/5 can't reduce that. But if you look across 8 and 5, you can't really, there's nothing common that can reduce both 8 and 5. But 3 and 9, let's circle that. We see that 3 and 9 can be reduced further. They have a common factor of 3. So we divide both 3 by 3 and 9 by 3. And then we're going to rewrite that or rename these fractions. So now this becomes 8 over 9 divided by 3 is 3. And then 3 divided by 3 is 1. And then it's still over 5. So that doesn't change. So now we have a new name for these fractions by cross-canceling. Now simply multiply across. So 8 times 1 is 8. 3 times 5 is 15. And we look and say, can we simplify that any further? No, we can't. So by cross-canceling at the beginning, it allows us to not worry about this extra step. Plus the numbers are smaller to deal with anyways. If we didn't cross-cancel, then we would have a larger set of numbers, and then we'd have to simplify, and then that's where mistakes happen sometimes when we deal with really large numbers. So that's why we want to try and cross-reduce or cross-cancel at the beginning. Let's try another example, why don't we? Just to see if we can get this down straight. Okay, so let's go 4/3. And we know that's improper fraction, but that's what we want it to be in. We want it to be in a fractional form, not mixed number, times 1/2. Okay, so now let's look at cross-canceling. So 1 and 3, we can't really do anything about that. But 4 and 2 in this hand, I noticed that these can be divisible by 2. So the same factor of 2. There you go. So we're going to rewrite this, rename these fractions, and this is 4 divided by 2 is 2. It's over 3 still. And then the 1 stays the same, nothing's happened to it, but 2 divided by 2 is 1. So now our final answer is 2 times 1 is 2 in the numerator, and the denominator 3 times 1, which gives us 2/3. So now that is the final answer. So now that we looked at multiplying fractions, what happens when we're introducing mixed numbers in the multiplication of fractions? So it's pretty much the same procedure. We have an extra added step at the beginning, which is to convert all mixed numbers into an improper fraction form. So then we can multiply it out. Okay, so in our notes, let's write down, change mixed numbers to improper fractions. That's kind of important. And then we follow the same procedure as we did with fractions multiplication, which is to cross-reduce or cross-cancel if possible. So we want to do that at the beginning so that we can make the numbers easier to manage as we go along. Instead of waiting at the end, if we don't cross-cancel or cross-reduce at the beginning, then our numbers at the end will be really large, and sometimes that can be difficult to reduce, and it might lead to mistakes and wrong answers. So after we get to this point, we're going to multiply the numerators by the numerators. So that stays the same. That's pretty easy. And then the denominators, of course, multiply together. We don't have to worry that they're the same. We just multiply across, and that makes it so much easier. Okay? And then lastly, the last step is always to simplify whenever possible. So again, it's possible that even though we cross-cancel at the beginning or cross-reduce at the beginning, we may end up getting an improper fraction value at the end, and then we have to reduce it or rename it, simplify it into a mixed number form. So let's look at some examples. Let's see if we can figure this out together and see what it looks like. So first example I'm going to give you would be 2 1/5. Ooh, we've got a mixed number alert, times 3 1/10. Ooh, another mixed number alert. Oh, wait a minute, they have different denominators. Doesn't matter. We're multiplying, doesn't matter. So before we do anything else, we have to convert it into an improper fraction. So remember, 2 times 5, that's going to be the whole number times the denominator. We're going to add that extra 1/5. Okay, so again, that is the process of converting a mixed number into a proper fraction. And then we do the same thing on this side, on the next fraction, or mixed number, excuse me. So 3 times 10. And then, of course, we add that 1/10. And then, of course, it's a 10th. So now we're going to rename these mixed numbers into 2 times 5 is 10, plus 1 is 11, so it's 11/5. 3 times 10 is 30, plus 1 is 31/10. Okay, so I already know this is going to get really ugly really fast. So what can we do to make this our life easier? Well, let's cross-cancel or cross-reduce if we can. Let's see, is there any place that we can do that at? I don't know. Doesn't look like it this time. So unfortunately, that's what we're going to have to deal with. And it's going to get ugly. That's the bad thing about sometimes it doesn't work out. But that's okay. Let's work it out. So 5 times 10, let me do the easy one. That's easy. That's 50. And then 11 times 31. And this is where, it's okay to use a calculator because it's more important that you are able to calculate the answer quickly. And so we go with 11. I'm sure you can see that. Times 31. And that gives me 341. So 341 over 50. Now I want to reduce that so that I can make this into a mixed number. So let's simplify that. So 341, I need to divide that. So let me put it on the side here. 341, divide that by 50. What do I get? So let's see. 341, divide that by 50. I'm going to get 6 and then blah, 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 something left over, right? So I know the answer up here is going to be 6. So 6 times 50 is 300. I know that. And so the remainder I get is 41. The remainder is 41 over 50. So what I get here is 6 is my whole number. 41 is the remainder. The divisor originally was 50, so it stays 50. And I can't reduce 41 over 50, so that remains 6. 41 over 50, that's the answer. Okay, Let's do one more example, just to keep going along the way. I always like having examples for you guys so that you guys can see the work and how it works out. So on this one, I'm gonna write it out. It's 3 3/7 times 1 5/16. Okay, so I'm gonna pause right here, and you can pause right here also in the video, and I want you to work out this problem on your own and see if you can figure it out. And then once you figure it out or try to work it out on your own, then play the video again and see if you've gotten the steps the way that I've had it completed. Okay, so we'll come back in 3, 2, 1. Okay, we're back, and let's see if you figure this out. So first things first, I wanted to convert these into improper fraction form. So I circled the whole number with their denominators here on each mixed number. So 3 times 7 plus the 3 is right here. And then it's still over 7. And then the next mixed number becomes 1 times 16 plus the 5 over the 16. And so now I'm going to rewrite both fractions, mixed numbers into improper fraction form. And I'm going to get 24 over 7, because 3 times 7 is 21, plus 3 is 24. And then 1 times 16 plus 5 is 21, so 21 over 16. So I'm going to cross reduce and cross cancel, and I see that 7 and 21 can be divisible by 7, so 7 divided by 7, and 21 divided by 7. And I'm going to get here, 21 divided by 7 is 3. And then 7 divided by 7 is 1. Okay. I'm going to look over here also. Can I cross cancel anything between 16 and 24? And the answer is yes. Okay. At the very least, it can be divisible by 2, but I know that's going to be 8. 8 can divide into both 16 and 24. Okay. So 24 divided by 8 will give me 3. And then 16 divided by 8 will give me 2. So it's getting a little messy here, and so I always like to rewrite the problem so I know what numbers I'm dealing with. Okay, so this is going to be 3 over 1 for the first set of improper fractions. The second set is 3 over 2. And then when I multiply it out, I get 9 over 2. And then, of course, this is an improper fraction. So I know that 9 divided by 2, let's just work it out completely so you know what I'm doing. 9 divided by 2, I get 4. 4 times 2 is 8. The remainder is 1. Okay, and it's over 2, of course, the divisor is 2. So it's going to look like this. It's going to look like 4. Remainder 1. Over 2. Okay, and so that would be my final answer for that. Okay, good job, everybody. We'll see you tomorrow in class. Don't forget there's a quiz. It's open notes.
It don't matter if you're young or you're old. Here we go. We gonna show you how it goes.